sp3 hybridization. Okay, sp3 hybridization, sp3 hybridization, sp3 hybridization. Okay, when one s and 3p, when s and 3p orbitals combine together, combine together and form 4 new orbitals and form 4 new orbitals, form 4 new orbitals of similar energy and shape, of similar energy and shape, This type of mixing of orbitals, is known as sp3 orbitals, sp3 hybridization. Okay, sp3 hybridization. And hybrid orbitals thus form are called tetrahybrid orbitals. And hybrid orbitals thus formed are called tetrahedral hybrid orbitals. Okay, tetrahybrid orbitals. Okay, then S, Px, Py and Pz gives four hybrid orbitals. At an angle of 109 degree 28 minutes. Okay, and give tetrahedral structure and give tetrahedral structure. Okay, the sp3 hybrid orbitals are directed towards the corner of a tetrahedron, and the angle between them is 109 degree 28 minutes. Each sp3 hybrid orbital has 1/4 of s. Each sp3 hybrid orbitals has 1/4 1/4 cs of s and 3/4 th of p character. Okay, p character. Okay, when 1s and 3p, when 1s and 3p, when 1s and 3p orbitals combine together and form 4 new orbitals of a similar energy and shape, this type of mixing of orbitals is known as sp3 hybridization. Okay, and hybrid orbitals formed called the tetrahedral hybrid orbitals. Okay, tetrahedral hybrid orbitals. Okay, and S, Px, Py and Pz 1, 2, 3, 4 gives 4 hybrid orbitals at an angle of 109 degree 28 minutes and gives the tetrahedral structure. Okay, each sp3 hybrid orbitals has 1/4 of s, 1/4 of s and 3/4 and 3/4 of p characters. Okay, as an example methane CH4, SiH4, SnBr4 and NH3, H2O, PCl3, SO4, double cation, CIO and so on. Okay, and 1s orbital, and this is 1s orbital. This is 1s orbital, 1s orbital. This is 1s orbital, s orbital, and next is a 3p orbital. 3p orbitals is also like this. This is Z, this is Y, and this is X. This is X, okay? This is a 3p. This is 3p orbital. 3p orbital. This is 3p orbitals, okay? This is 3p orbitals. And after hybridization, this is also converted as like this is also converted this is the angle of this is 109 degree 28 minutes. Okay, this is 4 sp3 hybrid orbitals, okay, hybrid orbitals, okay. Formation of CH4, formation of a CH4 molecule, methane gas. Okay, molecule. The electronic configuration of combining atoms carbon and hydrogen are carbon C6 aromatic of 1s2, 2s2, 2px, 1, 2py1 and 2pz1, okay, and H1 aromatic of 1s1, 1 unpaired electron, 1 unpaired electron, okay, electron, one unpaired electron. Okay. C grounded state, carbon in grounded state. If carbon in grounded state, 1 minute. Grounded state, okay. Electronic configuration of 6 carbon is 1s2, 2s1, 2px1, 2py1, 2pz1, and hydrogen is 1s1, that is 1 unpaired electrons, okay. And the C ground part and the C ground state. Ground state of carbon. Ground state of carbon is this is 1s2 and this is this is a 2s2, this is 2s2, and this is in p orbitals 3 brackets, and only 2 electrons, because 2 to 4, this is not this is 2p1, this is 2pz 0, then only 2 electrons, 1, 2 electrons, okay. And carbon in excited state, carbon in excited state, carbon in excited state is this is only 1 electron, and 1 electron is also go in the next p orbit, okay. Then this value is 2s1, and this is a 2px1, 2py1, and this is 2pz1. This is the excited state of carbon. And so CH4 is also converted into 1 electron, 4 hydrogen combined with this to complete the bracket. So 4 hydrogen. This is the carbon, and after hydrogen, 4 hydrogen join together, then the value is converted in this form as like this. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. This is tetrahedral structure. This is tetrahedral structure, okay. Tetrahedral structure, okay. And how to convert together? This is a formation of methane molecule by sp3 hybridization is also. This is like hydrogen, okay. Hydrogen. Methane, sp overlap, all are sigma bonds. Methane, sp overlap, all are sigma bonds, okay. And this is a carbon, so carbon, this hydrogen, and hydrogen, okay. Hydrogen. This is hydrogen and hydrogen, okay. Okay. This is hydrogen, 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 hydrogen. Okay. This is like tetrahedral. This is like tetrahedral. Okay. Tetrahedral. And this is carbon. This is carbon. Okay. This is carbon. Carbon. And this is carbon. The structure is tetrahedral. Formation of a methane molecule by sp3 hybridization. Okay. Formation of ammonia. Formation of ammonia. Formation of ammonia. Next is formation of ammonia. Formation of ammonia. NH3. Okay. NH3 is formed by sp3 hybridization. The electronic configuration of nitrogen is N7 is 1s2, 2s2, 2px1, 2py1 and 2pz1. Okay. This is 1s in 1s and this is 2s. This is 2s. This is 2s and this is 2p. Okay. sp3 hybridization, sp3 hybridization. Okay. sp3 hybridization. This is ground state. This is ground state and is also converted in this is 4 sp3 hybrid orbitals. This is 4 sp3 hybrid orbitals. Okay. 1, 2, 3, 4 sp3 hybrid orbitals and ns3 molecules is converted as like 1 hydrogen. Okay. 1 2s and 3 2p orbitals of nitrogen atom. Okay. 1 2s and 3 2p orbitals. 1 2s and 3 2p orbitals of nitrogen atom hybridized to form 4 sp3 hybrid orbitals. One hybrid orbital contains a lone pair of electrons and the rest 3 contains 1 electron in each hybrid orbital. 3 contains 1 electron in each hybrid orbitals NH3 molecule is formed by the overlap for 3 sp3 orbitals of nitrogen atom with 1s orbitals of hydrogen atom. Okay. The distribution of orbitals should be tetrahedral according to hybridization. 3 of the orbitals are used for bonding and each contains shared pair of electrons dp, while the fourth orbital contains lone pairs. Okay, while the fourth orbital contains lone pair. Okay, so the formation of ammonia NH3 is like this is hydrogen, hydrogen, hydrogen and hydrogen. Okay. Okay. Lone pair of electrons. Lone pair, sorry, this is not hydrogen. Only lone pairs of electrons. Okay. Only lone pairs of electrons. Okay. 1, 2s, 1, 2s and 3. 1, 2s and 3, 2p orbitals. 1, 2, 3, 3, 2p orbitals. Because p are 3p orbitals. Because in p orbitals 3 orbit. Okay. Then 1, 2s and 3, 2p orbitals of nitrogen atom hybridize to form 4. 1, 2, 3, 4. 1, 2, 3, 4 sp3 hybrid orbitals. One hybrid orbitals contains lone pair. One hybrid orbitals contains lone pairs. One hybrid orbitals contains lone pair of electrons and the rest 3 contains one electron in each hybrid orbitals. Okay. NH3 molecule is formed by the overlap of 3 sp3 hybrid orbitals of nitrogen atom with 3 1s orbitals of hydrogen atom. The distribution of 4 orbitals should be tetrahedral according to hybridization. The 3 of the orbitals are used for bonding and each contains a shared pair of electrons, while the fourth orbital contains a lone pair. Okay. The shape of NH3 molecule is pyramidal. The shape of NH3 molecule is pyramidal or distorted tetrahedral geometry repulsion. Distorted tetrahedral geometry repulsion between these orbitals are not all equal strength. The lone pair of electrons repels the other bonds pair. The other bonds pair shortly, hence it reduces the bond angle. Hydrogen, nitrogen form 109 degree 28 minute to 107 degree, and this structure is a hydrogen, and this is lone pair of electron. This is the nitrogen. Okay. And this structure as like this. Okay, as like this. Okay, and next is the structure of PCl3. 3. Next is structure of PCl3. Okay, PCl3. Okay, next structure is PCl3. Okay, formation of PCl3, structure of PCl3. PCl3 is also formed by sp3 hybridization. It has three bond pair. It has three bond pair and has one lone pair. One lone pair. Okay, three bond pair and one lone pair. Okay, PCl3 is also formed by sp3 hybridization. It has three bond pair and one lone pair of electrons in the fourth orbitals. Okay, it has pyramidal geometry. Which geometrical? Pyramidal. Okay, pyramidal geometry. Okay, in PCl3 molecule, the central atom lies. The central atom P lies at the center of a tetrahedron. Okay, tetrahedron. The three PCl bond are directed towards the three corners of the tetrahedron, while the fourth corner is occupied by a lone pair. When fourth is occupied by lone pair. Okay, the electronic configuration of central atom P in PCl3 as P15 equal to 1s2, 2s2, 2p, 2p6, 3s2, 3p3, and this is a 1s2, this is 2s2, this is 2p6, 1, 2, 3, 4, 5, 6. This is 2p6 and this is 3s2. This is 3s2. This is 3s2 and 3s2 and this 3p. This is 3p. Okay, this is 3p. This is the sp3 hybridization. Okay, this is sp3 hybridization and it also converted in fourth orbitals. This is as like this is 4 sp3 hybrid orbitals. Okay, sp3 hybrid orbitals. The electronic configuration of chlorine is given as 1s2, 2s2, 2p6, 3s2, 3px2, 3py2 and 3pz1. The central atom P forms 3 sigma bond. The central atoms P The central atoms P forms 3 sigma bonds by the overlap of sp3 by overlap sp3 3 pz orbitals. Okay, so PCl3 molecule has, this is and okay, due to presence of one lone pair, the geometry of PCl3 becomes pyramidal. Okay, pyramidal as lone pair bond pair repulsion is greater than bond pair repulsion. Okay, hence bond angle HPH between bonds pair decreases. Okay, thank you. And next is dsp2 hybridization. dsp2 hybridization. Okay, dsp2 hybridization. First is and the figure is this is like lone pair and this is chlorine. This is chlorine. Okay, and next is dsp2 hybridization. Next is dsp2 hybridization. 1 minute. Next is dsp2 hybridization. Okay, 1 minute. Next is dsp2 hybridization. Okay, dsp2 hybridization. Okay, combination of one dx square minus y square and 1 s and 2p orbitals px and py okay, px and py gives 4 equivalent hybrid orbitals. The lobes of 4 dsp2 hybrid orbitals are directed towards the corner of a square planar. These 4 hybrid orbitals lie in xy plane and are at 90 angle. Okay, combination of one dx square minus y square and 1s and 2p 1s and 2p orbitals px and py gives 4 equivalent hybrid orbitals. The lobes of 4 dsp2 hybrid orbitals are directed towards the corner of the square planar. These 4 hybrid orbitals lie in xy plane and are at angle 90 degree. Okay, and are at 90 degree angle. As an example, PTCl4 minus 2 NiCN4 minus 2 power and NH3 whole 2 Cl2 etc. Okay, this type of hybridization occurs in complex compound or geometry square planar. This type of hybridization occurs in complex compounds or ions. Complex compounds or ion geometry is square planar. Geometry is square planar. Geometry is square planar. Okay, and next is sp3d hybridization. Fifth is sp3d hybridization or dsp3 hybridization. Okay, dsp3 hybridization. Okay, when one s 3p and 1d orbitals of an atom combined and form 5 new orbitals. Okay, when 1s 3p 1d and 1d form 5 new orbitals which are called sp3d hybrid orbitals. sp3d hybrid orbitals. These 5 hybrid orbitals are directed towards the corner of a triangle bipyramidal. Bipyramidal. 3 sp3d hybrid orbitals are at an angle. 3 sp3 hybrid orbitals are at angle 120 degree with one another in triangular plane, and the fourth and fifth are perpendicular above and below the plane. Okay, all the 5 sp3 hybrid orbitals not equivalent. All the 5 sp3d orbitals are not equivalent. The 3 sp3d orbitals which are directed towards the vertices of an equilateral triangle are planar and known as equatorial, and the 2 perpendicular hybrid orbitals are known as axial. The bonds formed by equatorial hybrid orbitals are equatorial bond, whereas the bonds formed by the axial hybrid orbitals are axial bonds. The equatorial bonds distances are the same but are shorter than 2 axial bond lengths. Okay, this fact confirms that the 5 sp3d hybrid orbitals are non-equivalent in nature. The equatorial orbitals have less energy than the axial, hence equatorial bonds are more stable than the axial bonds. Okay, example Example, as an example, PCl5, PF5, BRF5, CIF5, SF4, etc. Okay, formation of PCl5 molecule. Okay. The electronic configuration of P is given by P15 is 1s2, 2s2, 2p6, 3p3 and 3d 0. Okay. Then 3s2, 2 to 4, 6, 10, 3, 12, 3s2. Okay. Then of 3s2, this is 3s2 and 1, 2. This is 3p. 3p3 is a 3p3 and p atom in ground state. The 3d. Okay, this is 3d 0. Okay, p atom in ground, p atom in ground. Okay, in ground state. Okay, and after some times this is a 3p3. This is 3p3 and this is 3d1. So this is also converted in 3d1. 3d1. P atom in excited state. P atom in excited state. Okay. So after hybridization, 1, 2, 3, 4, 5. Okay, 5. This is 1, 2, 3, 4, 5. sp3d hybridization. This is sp3d hybridization. Okay, this is sp3 hybridization. Excited p atom has 5 unpaired. Half-filled orbitals which combined to form 5 new sp3d hybrid orbitals. These 5 sp3d hybrid orbitals form 5 sigma bond with pz orbitals of 5 chlorine atoms. In this way, PCl5 is found. PCl5 has trigonal bipyramidal structure. The 3 bonds angles are 120. The 3 bonds angles are 120, while 2 are 90. 3 bonds angles are 120, while 2 is 90 degree. As the structure of PCl5 is unsymmetrical, is unsymmetrical, unsymmetrical, okay, unsymmetrical. Hence it is unstable and very reactive. Hence it is unstable and very reactive very reactive. When PCl5 is heated, the weaker. When PCl5 is heated, the weaker axial bonds breaks. If PCl5 is heated, okay. If PCl5 is heated, the weaker axial bond breaks. So PCl5 molecule dissociates as a PCl5 is a PCl3 plus a Cl2. PCl3 plus a Cl2. Okay, and this is as like okay, this is S, Px, Py, Pz and dz square. Trigonal bipyramid. Trigonal bipyramid. Trigonal bipyramid, and this is a P. This is a chlorine and chlorine, okay, and this is also chlorine, okay, and this is fourth atom chlorine. This is fourth atom chlorine, okay. And next chlorine atom is a allyl. Okay, and the structure is also as like phosphorus, chlorine, okay, chlorine. This is This is 90 degree. This is 120 degree. This is 120 degree. And okay. And next is sp3d2. Next is sp3d2. Next is sp3d2. Okay. Next is sp3d2 hybrid. Next is sp3d2. sp3d2 or d2sp3 hybridization. Hybridization. Okay.